right, today I want to go through the beginning of quantum mechanics. I know, big words, little meaning. Basically, we're going to look at how the electron moves and how we know that it's around. First thing is we do have Bohr's model. And if you remember, Bohr is the one who said the electron is going to be in specific energy levels. So he took Rutherford's idea of we have the nucleus and we have electrons around it and actually placed them in areas, similar to how the planets move in our planetary galaxies. So here's the idea, is we have our nucleus. The electrons are going to move, and we know this because we've been able to detect what's called electromagnetic radiation. These are our radio waves, microwaves, infrared, visible, remember the Roy G. Biv, then ultraviolet, X-rays, and gamma rays. So we have them listed from our long wavelength, low frequencies, to the short wavelengths, or those high frequency ones, the very dangerous ones. Okay, so how can we find this? How do we know this is happening? Well, Bohr started us off with the idea of having these electrons, and he was able to have a way of detecting them and to calculate them. And he had some help with this. There's a lot of other scientists that have been involved in this process. But basically what happens is we have an electron, and it's sitting here at what we call ground state. Now, ground state is the most stable, so the atom loves this one. It's also where the electron is the closest to the nucleus. All right, closest to that nucleus. Being closest means it also has the lowest potential energy. So ground state, closest to the nucleus, most potential energy, it's the most stable. Now, things don't always stay stable, okay? We could have some sort of form of energy, maybe electricity, or the sun shines, or you bumped it in the energy transitions, and that energy comes in and it hits the electron. Well, the electron can do a thing called absorption, and it can gain that energy. By gaining the energy, it now can move to a new energy level. Which means it's got higher potential energy. And it literally jumps to a new spot. Now, just like my children are when they're on sugar, they can't stay there. Eventually the energy wears off and it's given off and they have a sugar crash. So does my electron. The electron, being in this new state, it's called an excited state, has that full energy. It's like my kids on sugar. Okay? So up here, the electron's further from the nucleus. And it has higher potential energy, but it is not stable. So just like my kids, they can't stay in that excited state. They have to drop back down and have their crash. The electron does the same thing, and it can drop to any of these energy levels. And in the process, it drops off energy. This is called emissions. So emission is the energy given off. And this returns the electron to a lower energy level. Now, the cool part is when it returns, it gives off some of this energy. This is what we detect as our electromagnetic radiation. And you know what? We can sometimes see it in the form of maybe blue light. Maybe one comes out being green. Maybe it's giving off something for our microwave. Yes, and it even gives off red light. Okay, so we can actually see the electron's effects when it goes through this process of ground state, absorption, excited, and emissions based on how it transitions between those lower to higher and back down to the lower energy levels. And we can find these pieces. That is the beginning of our quantum mechanics.